So are you ready to have some fun? It's time for Pharmacology Math using the Burger Math method. I'm Mark Sowers. So let's take a look at this problem. The doctor ordered your patient to be given 275 milligrams of a drug. The drug is available in 0.5 grams per 2 milliliters. How many milliliters must you give? Now, I know what you're thinking. You're starting to sweat. You're starting to panic a little bit. I don't know. Well, that's okay, because by the end of this video, you're going to be able to solve problems just like this without making a mistake. Now, the method that I'm about to show you is a little bit different than what's taught in many health classes. So, a word of warning. If you have a system for solving problems like this that works for you most of the time, maybe it's cross-multiplying or something like that. If it works for you and it works for you most of the time and most of the time you're able to get the right answer, then you're okay. Maybe you don't need to watch this video because I don't want to confuse you and mix things up for you. If you've got something that's working, keep it working. Now, if the method that you're using causes you to get confused sometimes, maybe it doesn't work as often as you would like it to, or maybe you don't even have a method to approach a problem like this, then stay with me, because by the end of this video, we're going to be able to solve problems just like this using Burger Math. Now, I know what you're thinking. What is Burger Math? Well, Burger Math is a method for solving problems just like this that is used by the top scientists and engineers around the globe. And the reason that they use it for solving very complex and difficult problems is because it virtually guarantees that they're going to get the right answer. And when you're doing things like building bridges, you want to make sure you're getting the right answer. So that's how powerful this method is, and that's why I'm recommending it to you, because it's going to help you get the right answer. Now, they use a big fancy term for this method. They call it dimensional analysis, which is kind of a scary term, but not really, because it's actually a fairly simple and straightforward approach. So we're just going to call it Burger Math. Now, before we get started, I do want to give a little shout out to Dr. Stephen Farmer at the University of Hawaii, Maui College. He's the one that introduced Burger Math to the world, and I'm going to draw several of my examples from his presentation, which you can find in the description below. Now, to understand Burger Math, you have to understand that SpongeBob is the greatest fry cook in the world. He's really good at cooking up hamburgers. And there's one rule that SpongeBob must follow. It's that every hamburger gets 3 pickles. That's the rule. You remember that one? Every hamburger gets 3 pickles. Now, this phrase, every hamburger gets 3 pickles, is known as a ratio. It could also be called a proportion. It could also be called a conversion factor. They all basically mean the same thing. So some books sort of break them up a little bit. In Burger Math, we're going to call them all the same thing. It's just a way of relating one thing, hamburgers, to another thing, pickles. So let's take a look at this phrase. Every hamburger must get 3 pickles. Well, we can write this mathematically. And the way we're going to do that is write it as 1 hamburger equals 3 pickles. All right, that makes sense. So 1 hamburger equals 3 pickles because every hamburger must get 3 pickles. But word problems, the problems that you're going to find on a test, could be written in English many different ways. It could be written as 3 pickles for every hamburger, in which case, mathematically, you could write that as 3 pickles equals 1 hamburger. Or it could be written as a hamburger has 3 pickles. Mathematically, 1 hamburger equals 3 pickles. Or how about 3 pickles per hamburger? Mathematically, 3 pickles equals 1 hamburger. Or 1 hamburger per 3 pickles. 1 hamburger equals 3 pickles. So you see what's happening here. Lots of different ways of saying the same thing in English with hamburgers and pickles on different sides of the sentence. And when we write it mathematically, we could write it with hamburgers on one side and pickles on the other, or the other way around. It still means the same thing, whether you start with hamburgers and you end with pickles, or you start with pickles and you end with hamburgers. On each side of the equal sign, it doesn't matter. It still means the same thing. Now let's take a look at this phrase, 3 pickles per hamburger. Now, another way of writing per is to use the little slash. So we could write it as 3 pickles per hamburger. Now, what does this mean? Well, a way of writing this mathematically would be 3 pickles over 1 hamburger. It still means the same thing. When it comes to ratios and proportions, 3 pickles equals 1 hamburger, and 3 pickles over 1 hamburger means exactly the same thing. It's just another way of writing it. Now look at the next one, 1 hamburger per 3 pickles. Now if we were to use the slash and then write this one mathematically, we would write it as 1 hamburger over 3 pickles. But that's different than what we wrote before. But that's okay, it still means the same thing. Yes, if you write it 1 hamburger over 3 pickles, or 3 pickles over 1 hamburger, in ratios and proportions, it still means exactly the same thing. Just like when we're on both sides of the equal sign, we could write it this way, or we could write it this way. When it comes to ratios and proportions, we can write it this way, or we can write it this way. It still means the same thing. It's still equal. Now, because they mean the same thing, 3 pickles over 1 hamburger, or 1 hamburger over 3 pickles, they mean the same thing, I'm going to let you in on a little secret. Take a look at this label for heparin. Notice where it says here, 50,000 units per 10 milliliters. Now here's the secret. Another way of writing that is 10 milliliters per 50,000 units. It means exactly the same thing. This is just the convention that label makers tend to write things in, but it doesn't have to be written this way. It can be written the other way. It can be written vertically, 50,000 units over 10 milliliters, or 10 milliliters over 50,000 units. It means the same thing because you're saying what the number represents. It's not just an abstract number, 50,000 over 10. You're saying 50,000 units over 10 milliliters. And when you have those words that go with the numbers, you're defining what those numbers represent. And that is what allows you to make this switch vertically from one over the other or the other over the first. Now, one reason some people get nervous when it comes to pharmacology math is because sometimes it involves really big numbers or lots of units and it gets kind of confusing. Take, for example, this. 1,748 times 923. Wow, that's going to be a really big number. And it's not something that I'm able to do in my head. I'm going to have to get a calculator or something to figure this one out. But let's see if we can make this easier. How about this? 1,748 times 1. Well, you know what this is. Any number times 1 is itself. So 1,748 times 1 is 1,748. See how easy that is? You know how to do this. Now, wouldn't it be great if all questions could use 1? Well, I'm going to show you how we can use the power of 1 to make pharmacology math questions a whole lot easier. Well, the reason that 1 makes things so easy is because you can essentially ignore it. You can cross it out. You can get rid of it. So pretend it's not even there because it's not really doing anything, right? So 1,748 equals 1,748. Well, that's pretty easy. So we want to use 1 wherever we can. So what else equals 1? Well, what about this? 1,748 times 1 over 1. Well, what does that equal? Well, anything divided by itself is just 1. So 1 over 1 just equals 1. So the answer to this, 1,748. So here's a little harder one. How about 1,748 times 85 over 85? Well, that's actually still just as easy because 85 over 85, anything over itself, is still equal to 1. So actually what happens mathematically is the 85s cancel each other out. Think of it this way. If we take 1,748 or any number, we multiply it by 85 and then divide it by 85, divide it by exactly the same thing, we're just undoing what we just did. First, we multiplied it by 85 and then we divided it by 85. We're just undoing it. It's like hitting the undo button on your computer. It makes it like it never even happened. So whenever we see something over that same something, we can recognize that essentially what's happening is they're canceling each other out. We're doing something and then we're undoing it, so we can ignore both of them. They cancel each other out. And that canceling out of something over something that's the same is very important to burger math. All right, so let's try another one. How about 1748 times Squidward over Squidward? All right, so we just learned that when we have anything over itself, they just cancel each other out. So Squidward cancels out Squidward, and we're left with 1748. And what does that equal? 1748. So if you understand this concept, that whenever you have something on top and that same something on the bottom, and they can just cancel each other out, if you understand that concept, you're a long way to understanding burger math. So to help practice this, let's play a little game. Here's some of your favorite characters from SpongeBob. And here's the game. Here's the question. Mr. Krabs has a secret, and he doesn't want SpongeBob to find out. So what chain of events led to SpongeBob finding out? So here are some relationships that we know. We know that SpongeBob and Patrick like to talk to each other. We know that Squidward and Mr. Krabs like to talk to each other. We know that Squidward and Sandy like to talk to each other. And we know that Patrick and Sandy like to talk to each other. So to figure out what chain of events led to SpongeBob finding out the secret, we're going to set this up mathematically. And this setup that we're going to use here is the one we're going to use throughout the rest of the video. We're going to start by drawing a long horizontal line followed by an equal sign. So what's the question asking? It's asking, how did SpongeBob find out? So since that's what the question's asking, we're going to put SpongeBob after the equal sign because that's what we're trying to find out. Now, where are we starting? Well, we're starting with Mr. Krabs has a secret. So all the way over on the left on the top of the bar, we're going to put Mr. Krabs. So now we know our starting point and our ending point, starting with Mr. Krabs, ending with SpongeBob. And all we have to do is fill out the chain between them. So for the next step, we're going to draw a vertical line just to keep things neat. So right now it says that Mr. Krabs equals SpongeBob, and that's not true. We know that's not true. So we need to find a way of making this true. And to do that, in order to equal SpongeBob, because that's where we want to end up, we want to get rid of Mr. Krabs. And how can we get rid of Mr. Krabs? Well, we can cancel him out. Now remember what I said before, canceling something out means you can get rid of it. We can ignore it. So how are we going to cancel out Mr. Krabs? Well, we're going to do that by using one of the relationships that we see up top. So let's look at these and see if we see one that has Mr. Krabs in it. Well, sure, here's one. Squidward and Mr. Krabs like to talk to each other. So how can we write that relationship mathematically? Well, we can write it as Squidward over Mr. Krabs or Mr. Krabs over Squidward. Squidward over Mr. Krabs or Mr. Krabs over Squidward. They both mean the same thing. So which version are we going to use? So in order to cancel out Mr. Krabs on the top, we need Mr. Krabs on the bottom. So the way we're going to write our relationship is Squidward over Mr. Krabs. And now that Mr. Krabs is both on the top and on the bottom, we can cancel each of them out. And we're left with Squidward. Well, Squidward doesn't equal SpongeBob, so let's see if we can find another relationship to cancel out Squidward. Again, we want to cancel out Squidward. So here's one. Here we have Squidward and Sandy. So how are we going to write this mathematically? Squidward over Sandy or Sandy over Squidward? Squidward over Sandy or Sandy over Squidward? Well, in this case, we have Squidward at the top. We want to cancel Squidward out. So we're going to put Squidward on the bottom. So we're going to write it as Sandy over Squidward. And with Squidward on both the top and the bottom, we can now cancel out both Squidwards. So Sandy still doesn't equal SpongeBob, so we have a few more steps to go. We'll draw our vertical line just to keep things neat, and then we'll find a relationship involving Sandy. Well, here's one. Patrick likes to talk to Sandy. So we're going to write that mathematically as Patrick over Sandy or Sandy over Patrick. Patrick over Sandy or Sandy over Patrick. Which one's going to work here? Well, we have Sandy on top. We want Sandy at the bottom in order to cancel the Sandys out. So we're going to write it as Patrick over Sandy. And when it's written this way, we can cancel our two Sandys out. See, now we're getting close. We only have one step left. Patrick and SpongeBob. What's the relationship there? Well, there it is. Patrick and SpongeBob like to talk to each other. We're going to write that mathematically as Patrick over SpongeBob or SpongeBob over Patrick. Patrick over SpongeBob or SpongeBob over Patrick. Which one's going to work here? Well, we have Patrick on the top. We want to cancel out Patrick, So we want Patrick on the bottom. And when we write it this way, SpongeBob over Patrick, we have Patrick on top, Patrick on the bottom. We can cancel out our two Patricks, and we're left with SpongeBob. Now, does SpongeBob equal SpongeBob? Yes, it does. So we've come to the end of our equation. We've solved the problem. We've found the chain of events that leads to SpongeBob. So if you were able to follow this, how we got from Mr. Krabs all the way to SpongeBob mathematically, now you're ready for burger math. So here's how burger math works. Remember our rule. Every hamburger must get 3 pickles. That's our rule. And the question is, how many pickles do you need to make 100 hamburgers? Now I know this is a very easy question. You can probably figure this one out in your head, but we're going to figure it out using burger math so that we can follow the steps to get that right answer. And we're going to do that because as the questions get harder and harder, we're going to use the exact same steps to solve these harder and harder questions. So let's try it on this easy question first that we pretty much already know the answer to. So we're going to set up our problem the same way. We have our horizontal bar followed by an equal sign. And we're going to look at the question and say, what is it asking? What is the question asking? It's asking how many pickles? That's the question. So how many pickles? That's what we're going to put to the right of our equal sign. Now on the left, we want to put our starting condition. Well, what are we starting with? We're starting with 100 hamburgers. We want to try to figure out how many pickles are going to go with 100 hamburgers. So that we're going to put over on the left. And now we need a relationship. Some relationship between pickles and hamburgers. Do we know a relationship between pickles and hamburgers? Yes, we do. We know that 3 pickles goes to 1 hamburger. Lots of different ways of writing that. We're going to write it mathematically. 3 pickles over 1 hamburger. Now, it could be written the other way. We'll figure that out in a moment. So down here in our equation, we're going to draw the vertical line just to keep things neat. And then we're going to write our relationship. Are we going to write it as 3 pickles over 1 hamburger? Or 1 hamburger over 3 pickles? 3 pickles over 1 hamburger? Or 1 hamburger over 3 pickles? Well, notice what we have here. We have hamburgers at the top. And we want to cancel out hamburgers because hamburgers doesn't equal pickles, which is on the other side. So we want to cancel out hamburgers. And the way we're going to cancel out hamburgers is by putting hamburgers on the bottom. So we're going to write it as 3 pickles over 1 hamburger. And then we can cancel out hamburgers. And when we do, we're left with pickles on this side of the equation. What is on the other side of the equation? Pickles. Well, guess what? We've already come to the end. That was pretty easy. So now what do? Well, we have our numbers here. Let's deal with them. And the way we're going to deal with them is very easy. All the numbers above the line, we're going to multiply. And all the numbers below the line, we're going to divide. So numbers on the top of the line, multiply. Numbers below the line, we're going to divide. So let's do it. We have 100 times 3, which is 300, divided by 1. Now, just like anything times 1 is itself, so anything divided by 1 is also itself. So 300 divided by 1 is still 300. So our answer is 300 pickles. Now, I know what you're thinking. You could have done this in your head in about 5 seconds, and here it took me over 2 minutes to draw this little diagram and cancel things out and figure out the answer. Well, that's true. But as the problems get more difficult, you're going to see how this diagram really helps you out. So let's take a look at a problem that's a little bit harder. How many hamburgers can you make with 732 pickles? Well, again, we're going to approach this exactly the same way. We're going to start by drawing our horizontal line, followed by an equal sign. Now on the right, we're going to put, what is the question asking? Well, the question is asking, how many hamburgers? That's the question. So on the right side of the equation, we're going to write, how many hamburgers? On the left side, we're going to put our starting condition. What are we starting with? Well, we're starting with 732 pickles. So we're going to write 732 pickles. And because pickles doesn't equal hamburgers, we need a relationship between the two so that we can cancel pickles out. Now, what's a relationship? Oh yeah, we remember this one. 3 pickles for every 1 hamburger. So let's go through the steps. First, we're going to draw a vertical line just to keep things neat. Then we're going to use our relationship. 3 pickles over 1 hamburger, or 1 hamburger over 3 pickles. 3 pickles over 1 hamburger, or 1 hamburger over 3 pickles? Which one are we going to use here? Well, we have pickles at the top and we want to cancel out pickles. So we're going to put pickles at the bottom. We're going to use 1 hamburger over 3 pickles. And when we do, we can cancel out our pickles and we're left with hamburgers, which is what the question's asking. It's asking for hamburgers. So hamburgers equals hamburgers. Everything's good. Now we deal with our numbers. We multiply everything across the top and then divide by everything below the line. So here we have 732 times 1. Well, that's easy, 732, divided by 3. And using our handy-dandy calculator, we figure out that that equals 244. So we could make 244 hamburgers with 732 pickles. You see how we didn't have to think about it. We didn't have to figure out, okay, do I have to multiply by 3? Do I have to divide by 3? What am I doing here? We just follow the process. The numbers come along and it automatically tells us what we have to multiply and what we have to divide. It makes it very difficult to make a mistake. So let's try it with an even harder question. There are 732 pickles in a jar. There are 6 jars in a case. How many hamburgers can we make with 1 case of pickles? So it looks like there's going to be a couple of steps to this problem, but that's okay. We're going to set it up exactly the same way. We're going to have a horizontal bar followed by the equal sign. Now on the right of the equal sign, we're going to put, what's the question asking? The question is asking how many hamburgers. So we're going to put how many hamburgers. Now, what are we starting with? Well, we're starting with 1 case of pickles. So we're going to put 1 case all the way over on the left. Now, let's see if we can find some relationships that were given in this problem and see if we can write them mathematically just to have them handy. All right, so let's start with the first line. There are 732 pickles in a jar. How can we write that mathematically? Well, how about 732 pickles per 1 jar? Okay, that sounds pretty good. Now we could write it the other way, 1 jar over 732 pickles. It still means exactly the same thing, but we're just going to write it this way just to keep it handy for now. Let's look at the second line. There are 6 jars in a case. So written mathematically, we can write that as 6 jars over 1 case. Again, we could flip-flop it. We're just writing it one way to keep it handy for now. So let's go down to our equation and start plugging those in. So we're starting with 1 case. And case doesn't equal hamburger, so we want to cancel out case. So what are we going to use? Well, we're first going to draw our vertical line just to keep things neat. And then we're going to look for a relationship that involves cases. Well, here's one, 6 jars over 1 case. So that's the one we're going to use. So in our equation, are we going to write it as 6 jars over 1 case or 1 case over 6 jars? 6 jars over 1 case or 1 case over 6 jars? Well, we have case on the top. We want to cancel that out. That means we're going to put case on the bottom. So we're going to write it as 6 jars over 1 case. And when we do, we can cancel out cases and we're left with jars. But jars still doesn't equal hamburgers, so we have to do another one. Draw another vertical line. Let's find another relationship. Any relationships involving jars? Well, yes, here's one here. 732 pickles per jar. So let's use that in our equation. Are we going to write it as 732 pickles over 1 jar or 1 jar over 732 pickles? 732 pickles over 1 jar or 1 jar over 732 pickles? Well, we have jar on the top. We want jar on the bottom. So we're going to write it as 732 pickles over 1 jar. And with jar on the top and jar on the bottom, we can cancel those two out and we're left with pickles. So does pickles equal hamburgers? Well, no, not quite. We still need one more relationship to convert those. Well, it looks like we've run out here. So now what do we do? Well, if we don't have any relationships in the question that we're asked, we have to find those relationships somewhere else. But we have a source in our heads, and we know a relationship between pickles and hamburgers. Remember the rule, 3 pickles per 1 hamburger. So how are we going to write this in our equation? Are we going to write it as 3 pickles over 1 hamburger or 1 hamburger over 3 pickles? 3 pickles over 1 hamburger or 1 hamburger over 3 pickles? Well, we already have pickles at the top. So in order to cancel out pickles, we want pickles at the bottom. So we're going to write it as 1 hamburger over 3 pickles. And when we do, we can cancel out our pickles and we're left with hamburgers at the top. And does hamburger equal hamburgers? Yes, it does. So we've come to the end. Now all we have to do is deal with our numbers. Now as I look at all the numbers here, I see a lot of ones. And remember, whenever we multiply something by 1 or we divide it by 1, it's not doing anything to the equation. We can pretty much ignore it. So let's just ignore all the ones. Make this simple, right? The goal here is to make things simple. So we're just going to ignore the ones because they don't affect the problem in any way. So with all the ones gone, let's multiply all the numbers on the top and divide by all the numbers on the bottom. Using our handy dandy calculator, we have 6 times 732, and that equals 4,392. Now 4,392 divided by 3 equals 1,464. So we've solved the question. 1,464 hamburgers is how many hamburgers we can make with a case of pickles. And that is a lot of hamburgers for Patrick to enjoy. All right, so that was cool. We were able to solve a fairly complex problem using the steps of burger math. So how can we apply this method to pharmacology math? Now don't worry, it's going to be just as easy as what we just did with hamburgers. All we have to do is figure out what's the question asking, what's our starting condition, and what relationships can we use. So let's take a look at this vial of heparin and see what information that we have. Well, we've got a couple of numbers on there that we can use. Great, we'll save those for a moment. What's the question? Well, the question is, how many units of heparin are in this vial? Now, this is a trick. You see that big 1,000 sitting there? That's not the answer. You know, it would be a little too easy if that were the answer. So let's solve this problem using burger math, following the exact same steps that we did before. To do this, we're going to start with a horizontal line, followed by an equal sign. And then we figure out, what is the question asking? Well, the question is asking how many units. So on the right side of the equation, we're going to write how many units. Then we have to figure out what's our starting condition. Well, our starting condition is this vial. So we're going to write 1 vial. Now, does vial equal units? No, it doesn't. So we want to cancel out vial. Well, we need a relationship involving vials. Let's look at our label and see if we see anything involving vials. Well, let's see what we have. Oh, down here, we see the word vial. So what does this say? It says 10 milliliter multi-dose vial. That's what this is. Another way of saying that is 10 milliliters per vial, or we could write it mathematically as 10 milliliters over 1 vial. So let's plug it into our equation. We're going to draw the vertical line just to keep things neat, and then we're going to write 10 milliliters over 1 vial, or 1 vial over 10 milliliters. 10 milliliters over 1 vial, or 1 vial over 10 milliliters. Well, we have vial on the top, and we want to cancel it out, so we're going to write it with a vial on the bottom. So we're going to write it as 10 milliliters over 1 vial. And when we do, we can cancel out our vials, and we're left with milliliters. What does milliliters equal units? No, not quite. So we have to do another conversion. That's okay. We're going to draw another vertical line just to keep things neat. Now, let's see if we can find a relationship written on the vial involving milliliters. Well, there's the big one right in the middle. 1,000 units per milliliter. So we're going to use that. That sounds like a good one. So how are we going to write that? Are we going to write it as 1,000 units over 1 milliliter, or 1 milliliter over 1,000 units? 1,000 units over 1 milliliter, or 1 milliliter over 1,000 units? Well, we have milliliters at the top. We want to cancel that out, so we want to put milliliters at the bottom. So we're going to write it as 1,000 units over 1 milliliter. And when we do, our milliliters cancel each other out, and we're left with units. And does units equal units? Yes, it does. So that's how we know we've come to the end. Now all we have to do is deal with the numbers. Now look, there's a bunch of ones, so we can ignore all the ones because they don't do anything. And then we multiply everything along the top. So we have 10 times 1,000 equals 10,000. And we divide by everything on the bottom. Well, it was just ones on the bottom, so we can ignore them. So we don't even have to do a divide step. So our answer is 10,000 units. So I hope you're starting to see the power of burger math here. You don't have to worry about, am I going to multiply? Am I going to divide? How am I going to set this up? What order am I going to do things in? You always do it exactly the same way. You figure out what the question's asking, you figure out your starting condition, and you just build from there. And the equation builds itself automatically. You don't have to think too much about it. That's pretty cool. So let's try another problem. Remember that big scary problem that we had at the very beginning of this video? Well, right now you're going to see it's really not that scary. We're just going to solve it using burger math. So here's the question. The doctor ordered your patient to be given 275 milligrams of a drug. The drug is available in 0.5 grams per 2 milliliters. How many milliliters must you give? Well, again, we're going to solve this problem by setting it up exactly the same way that we've done all the other ones. It's exactly the same. We're going to start with a horizontal line, followed by an equal sign. Then we figure out what's the question asking. Well, the question's asking how many milliliters. So that's what we're going to put on the right side of the equation. Now we have to find out our starting condition. Well, we're starting with what does the patient need? Well, the patient needs 275 milligrams of a drug. So we're going to write 275 milligrams on the left. Now to keep things neat, we're going to draw a vertical line. Now we need a relationship. Are there any relationships that are given in the question? Well, yeah, here's one, 0.5 grams per 2 milliliters. So we can write that mathematically, 0.5 grams over 2 milliliters, and we'll figure out which way we want to write that in a moment, but there it is just so that we have it handy. So let's take this relationship and put it into our equation. Now, are we going to write it as 0.5 grams over 2 milliliters, or 2 milliliters over 0.5 grams? 0.5 grams over 2 milliliters, or 2 milliliters over 0.5 grams? Well,
Houston, we have a problem.
Yes, we do. Something doesn't match. Our starting condition is milligrams, and we want to cancel out milligrams. So if we have milligrams at the top, we need milligrams at the bottom. But this relationship that we have here doesn't have milligrams in it. It has grams and it has milliliters, but neither one of them is milligrams. So we need another relationship. Now, what are we going to use? Well, I don't see any in the question. So again, we have to pull a relationship from our heads. And hopefully you know some of the relationships in the metric system. So let's see. We're starting with milligrams. Do we know any relationships involving milligrams? Well, I hope you do. I hope you know that there are 1,000 milligrams in every gram. So that's our relationship. Let's write that down. 1,000 milligrams per gram. So let's take that relationship and put it into our equation. Do we want to write it as 1,000 milligrams over 1 gram or 1 gram over 1,000 milligrams? 1,000 milligrams over 1 gram or 1 gram over 1,000 milligrams? Well, we have milligrams on the top, so we want milligrams on the bottom. So we're going to write it as 1 gram over 1,000 milligrams. And when we do, our milligrams cancel out and we're left with grams on the top. So we have grams at the top. Grams still doesn't equal milliliters. So do we have a relationship involving grams? Well, yes, we do. Here it is. This is the original one that we started with. So 0.5 grams per 2 milliliters. So how are we going to write that? We're going to first draw our vertical line just to keep things neat. And then we can write it as 0.5 grams per 2 milliliters or 2 milliliters per 0.5 grams. 0.5 grams per 2 milliliters or 2 milliliters per 0.5 grams. Well, we have grams at the top, so we want grams at the bottom, so we're going to write it as 2 milliliters per 0.5 grams. Well, the grams cancel each other out, and we're left with milliliters. And does milliliters equal milliliters? Yes, it does. So we've come to the end. Now all we have to do is deal with the numbers. We're going to multiply everything on the top and divide by everything on the bottom, just like we did in every other problem. So let's do that. Get our handy dandy calculator out. We have 275 times 2, which is 550. 550 divided by 1,000, which is 0.55. And then 0.55 divided by, because it's still on the bottom, divided by 0.5 gives us 1.1. So our answer, 1.1 milliliters. And 1.1 milliliters is the correct answer. Now, isn't that cool? We were able to set this up using English, not necessarily using math, using English words, things like milligrams, grams, milliliters, words to set up this problem. And it's the words that we were using to build our equation, canceling one word out with the other. We didn't have to worry about the numbers. The numbers followed the words. So once we had all the words canceled out and all the words were set up the way we wanted, the numbers were already set in the right places, and we knew, did we multiply them or divide them? That's the power of burger math. It makes it very difficult to make a mistake. So let's take a look at one more problem, this one involving weight and dosages, so that I can show you the wide variety of problems that Burger Math can solve. A patient weighing 220 pounds is to receive a drug which is to be given at a ratio of 0.5 milligrams per kilogram. That means the dosage changes depending on the patient's weight. So how many milligrams should this patient receive? Well, just like all the other problems, we're going to set it up exactly the same way. We're going to start with our horizontal line and an equal sign. Now we're going to figure out what's the question asking. Well, the question's asking how many milligrams. So that's what we're going to put on the right side of our equal sign. So what's our starting condition? Well, our starting condition is a patient weighing 220 pounds. So 220 pounds is what we're going to put on the left side. And to get from one to the other, we're just going to plug in all the relationships that we know. So we're going to first start by drawing a vertical line just to keep things neat. We're going to find a relationship. Our relationship here is 0.5 milligrams per kilogram. So we can plug this in. Wait a minute. We're starting with 220 pounds. We're starting with pounds. We need a relationship involving pounds. Well, we don't have one. So what do? Well, we have to go to our brains and see if we can figure out a relationship involving pounds. Now, this one's fairly common, so I hope you know this one. And if you don't, you might want to memorize this one. The relationship between pounds and kilograms is 2.2 pounds for every kilogram. Now, another way of writing that, 2.2 pounds over 1 kilogram. So let's use this relationship in our equation. And we're going to write it as 2.2 pounds over 1 kilogram, or 1 kilogram over 2.2 pounds. Well, we have pounds at the top. We want pounds on the bottom. So we're going to write it as 1 kilogram over 2.2 pounds. And when we do, we can cancel out the pounds and we're left with kilograms. Now, kilograms still doesn't equal milligrams, so we have to do a conversion. And we have a relationship between kilograms and milligrams. In this case, kilograms of the patient's weight and milligrams of the drug. Don't get the two different weights confused. Now, that relationship is 0.5 milligrams for every kilogram. So how are we going to write this? Well, we're going to draw our vertical line to keep things neat. And then we're going to write it as 0.5 milligrams over 1 kilogram, or 1 kilogram over 0.5 milligrams. Well, we have kilograms at the top. We want kilograms at the bottom. So we're going to write it 0.5 milligrams over 1 kilogram. And when we do, we can cancel out the kilograms and we're left with milligrams. And does milligrams equal milligrams? Yes, it does. So we know we've solved it correctly. Now all we have to do is run the numbers. So again, we ignore all the ones. We can just pretend they're not even there. We're going to multiply everything on the top. So we have 220 times 0.5, which is equal to 110. Then we're going to divide by everything on the bottom. So 110 divided by 2.2, and that equals 50. So our answer, 50 milligrams, is how much this patient's going to receive. So I hope you can see how powerful this Burger Math method is. It doesn't matter if the problems are fairly simple or extremely complex, it keeps you on the right track. It makes sure that you're following the steps one to the next, and you're always going to end up setting up your equation correctly because it keeps you on the right track as you build your equation all the way through to the end. So here's what I recommend. If you think you've got this, great. Go ahead and find some questions on the internet or in some of your books, wherever, and try it out. See if this method works for you. And if it does, wonderful. If you're still not quite sure, here's a trick. Wait a day and then come back and watch this video again. Now, what this is going to do, it's going to be like watching one of those movies that has a surprise ending and you don't know it's coming. And then when you see that surprise ending and you go back and watch the movie again, suddenly everything makes sense. It's like, oh, I see this now. Oh, I see this now. So that's what I want you to do with this. Now that you know how this ends, go back, watch the video again, and you're going to see how every step fits in. It's going to make a lot more sense to you, just like those surprise ending movies. And once you truly understand it, you're going to be able to use this to solve many, many different types of questions. Good luck on Pharmacology Math.